Good afternoon, ePlaneteers, from me, Carl, here at the Access offices. This week I'm going to cast a critical eye over today's talks, except one of them was my own talk, so obviously I'm not going to do the critical eye for that. I'm going to have a look at one specific issue from Rob's talk on the origins of life. Origins of life is a fascinating topic. It's one that's intrigued scientists and humanity alike ever since people have started thinking and writing. And I think Rob does an excellent job of giving us an introduction to this subject. But there's one point that I think that doesn't really come through well enough. And so I'm going to show you just two slides today to really quickly make that. And it's called the primordial conundrum. And you see, in Rob's talk, he points out that as soon as life gets going, then the evolution of millions of species seems the almost certain result. And I completely agree with that statement. As soon as you get the chemical reactions of life happening, then that result appears to be inevitable. It will definitely happen. As soon as you get organisms that can pass on information from one generation to the next and can adapt to their circumstances, therefore, and can use energy, then eventually different adaptations, the evolution of species, all seems inevitable. But, and here's the really key thing in trying to understand the origin of life, in order for that to happen, you have this primordial conundrum that for the first, what we would call a living thing to exist and to go on to produce subsequent generations, it needs to do two very different things. It needs to deliver biochemical activity, i.e., it needs to find a source of energy in order to move, to do the processes of life, and in order to copy its genetic material, in order to have energy available for copying its genetic material, to pass something on. And then secondly, it needs to store that data. It needs to be almost like a computer disk. It needs to have information that's stored and can be replicated. And the information that's stored actually will tell you how to replicate itself and do the biochemical activity. But the biochemical activity is needed in order to produce energy to do that replication. So the two, it's a catch-22. The two need each other. Now in modern life, these are two very different molecules. You've got proteins, and these proteins make enzymes that you can see on the left of the screen here. Proteins are the ones that do biochemical activity. They're the ones that provide the energy for anything that the cell needs. They make ATP, they do stuff like that. Whereas on the other hand, in modern life, DNA is the molecule which contains the genetic code, which stores and replicates the data that the proteins are coded for. So in your DNA, all of the proteins that you need in order to move and to get energy and also to code to replicate your DNA are coded for in the DNA. So the DNA codes for proteins, but the proteins replicate the DNA. So they're both needed. And it's really difficult to envisage both of these spontaneously generating at once. And as I say, as soon as they are together and doing this two-step thing, the replicating, the making energy and replicating, the storing the data, pass on to the next generation improves, etc., etc. As soon as you've got that, then it seems certain that life goes on. But how do you get those two very different things to appear at once and together? Now that's a conundrum. And that's a really, really difficult one to explain with this modern system. And it also explains why Miller and Urey's experiment, whereas it was very significant, is not as significant as they thought. In Miller and Urey's experiment, as you'll remember from Rob's talk, the scientists took some of the early atmosphere and they exposed it to electrical charge. What they found was that made amino acids. These are the basis of proteins. But at the time, scientists thought that proteins were the chemicals that store data as well as the chemicals that do the biochemical activity. So Miller and Urey thought that they'd solved this conundrum because it was the one molecule that does both. But now, since the discovery of DNA, we know that different molecules do the biochemical activity and the replication. So we have a conundrum. How do we get around this? Well, there's one theory that does seem to very nicely get around this, and it's called the RNA world. And some of you might know that RNA is a single-stranded form of DNA. And RNA has some very, very special properties. That RNA can actually replicate itself. It can catalyze and provide the energy for its own reproduction. So this is a molecule that can do both biochemical activity, like a protein, but can store data like DNA. So some scientists believe that maybe the answer to this primordial conundrum is the fact that the first molecule of life on Earth was RNA. But then, of course, in the Miller-Urey experiment, RNA wasn't the molecule that was produced. So we still have more unanswered questions than we have answers. But that's always the beauty of science, and that's why research is so interesting. These questions all need young researchers to come and turn their attentions to them and find out the answers.